Hi everyone, I'm Adarsh and today I'll be talking on building federated GraphQL APIs using Flask. Let's get started by looking at various differences between REST and GraphQL. Let's look at a sample endpoint for getting a greeting message. In case of REST, we'll be issuing a GET request to the /greeting endpoint and we will get a greeting message as the response. Now coming to GraphQL, we can see that the endpoint used is /GraphQL and the request method is post. We are sending the operation name inside our post body, and similarly we are getting a response inside the data key with a greeting message in case of GraphQL. Now what if we need to set a custom greeting message? In case of REST, we will send a post request to the same endpoint with a new greeting message, and the server will respond with the modified greeting message. Coming to GraphQL, there are some differences. The request HTTP method as well as the endpoint remains the same, and inside our post body we are sending the operation name and the new greeting message. So the server responds similarly with the data key, our operation name and our new welcome message in the response. Now let's take a look at a few features of GraphQL. We saw that in case of REST, we have multiple endpoints like for operations related to greeting, setting or getting a greeting, we will define a URL path /greeting. Similarly, for other operations, we will go on with defining new endpoints. But as we have seen in case of GraphQL, there is only a single endpoint /GraphQL, and the operations are specified in the post body of the GraphQL operation. Now coming to the various set of operations in REST and GraphQL, we have seen that in REST we have a get operation which is commonly used to fetch data, and for adding, editing or modifying we have post, put, patch, etc. In case of GraphQL, the HTTP method used is post always. Then we have an operation called query for fetching the data. We have used this initially for fetching a greeting message. Then for modifying, updating, deleting, etc., we have an operation called mutation. So if we are mutating or changing the data, we will use the mutation operation. And similarly, we have another operation called subscription, which is for real-time persistent connection operations. Another distinguishing feature of GraphQL is its strong typing. The entire set of operations, the supported arguments, the return types, input types, everything is predefined and is exposed to the front-end clients who are consuming the API. So here in this example, I am using an API Explorer tool called Insomnia. Also, we can use other tools such as Postman or Bluedo with GraphQL support. So we are getting various errors like we are missing a required argument, but we have not provided that in our mutation. So these errors can be caught by the front-end teams without any help or consultation with the back-end team developing the API server. Now let's take a look at various scalars and types in GraphQL. Scalars are the basic types. So these include int, float, string, boolean and id types. Similarly, we have other types or containers like list. So list can contain multiple scalars together, and a non-null is a wrapper which marks a field as non-nullable. Then we have enums, union and interfaces. This is an example of an enumeration. So we are defining an enum called episode. So the episode can contain any of these string values. Next, we can define custom types. So these can be composed of multiple scalars or other existing already defined types. So we are in this case we are creating a custom type named character, and it has two fields called name and PSE. Similarly, we have union type. So here we define a search result union, and it can return either the human type or the droid type or the starship type in its response. Now let's take a look at various advantages of GraphQL. Uh, Initially, let's take a look at overfetching prevention. So consider the example of our REST API, which returned a greeting message. Suppose we are introducing desktop web clients and we require a greeting image to be sent along with the greeting message. This was our initial REST API. The option 1 is to add a new field to our endpoint and return the image URL in the response. So in case of mobile clients, the disadvantage is that an extra unused field is returned. So this field is only used in case of web clients. Another option is we can add a separate endpoint called greeting image, which returns the image URL separately. The disadvantage is that in case of web clients, we have an extra network call to get the image, and there is an added complexity. Now let's come to the GraphQL solution. This will be a query of the mobile client. The operation is greeting and we are requesting the message. So we're getting the requested data, the greeting message in the response. Now coming to the query for the desktop client, the operation is the same, the endpoint is the same. Along with the message argument, we are also providing the image URL in the query, and we are getting the entire set of fields we have requested in the response. So GraphQL allows us to query only the fields we need in case of multiple clients. So this will help us prevent the overfetching issue and defining multiple endpoints or adding additional fields to a single endpoint. Another advantage of GraphQL is its introspection and type system. As we have seen previously in the mutation with missing argument, GraphQL is strongly typed and schema based, and all supported operations by the server are returned by an operation called introspection. So our API client, so the front end can see the possible operations, its arguments, etc. Next, since we have the possibility of introspection, we know the types beforehand. So there exists a lot of tooling in a lot of languages to auto-generate client code. Next, if we need to hand off our API server to the client, we need additional documentation tools. So in case of Flask, we can use Flasker or Flask REST API libraries. But with GraphQL, it's built in. The GraphQL development is centered around its schema and type system. For building a GraphQL API using Python, we need to select a GraphQL server library. There are a number of options, and we can classify the GraphQL server libraries mainly as schema first versus code first. So let's take an example from a schema first library called Ariadne. Here we can see that we are using the GraphQL schema definition language to define our operations. Here we are defining a type called user, and it has two fields, ID and name. And we have a query called getUser, and we are accepting ID as the input, and it will return the user type as its return. Now for performing this operation, we have defined a Python function, a resolve getUser function, which returns the requested ID along with a dummy name for the user. So this is the schema first way. We are defining the types and the operations using GraphQL STL, and we express that as a Python string. Now coming to the code first solution, the code will be the source of truth. Here this is the corresponding API using a code first solution. This example uses the Graphene library. Here we can see the class user is created, which is a GraphQL type, which is defined as the fields are defined as ID and name, which are expressed as attributes of this class. So this class is inheriting from graphene.objectType class, which defines this, or which classifies this as a GraphQL object type. Similarly, we have a similar syntax for query, and we define the resolver in a similar way as that of Ariadne. So in the code first example, we are abstracting away the complexity of the SDL, GraphQL SDL from the user, and we are just using our Python objects for defining our GraphQL schema. So in this demo, I'll be using another code first library called Strawberry. Now let's see a small demo of these GraphQL concepts in action. Here are my requirements. I'm using the Strawberry GraphQL library. It's also a code first library, and it uses type annotations mainly to express GraphQL types and return types. Also, I'm using SQL Alchemy to connect to my database. Now I have created an initialize DB function. Here we are building a microblogging site, a simple microblogging API using GraphQL. So I have added the code to insert two dummy posts to our API. Next, we have the familiar app.py file from Flask. As we have seen before, there is only a single endpoint, and we are declaring the endpoint as a class-based view using the GraphQL view class, which is defined by the Strawberry library. Then we have these files inside our API directory. These are all related to the definition of our API. We have the types.py file. Consider this post type for now. We have defined a post with ID, title, and content. So if we need to output something in GraphQL, we need to first define a GraphQL type. So we are decorating this Python class using the strawberry.type decorator. So strawberry will convert them into a GraphQL type, and it will be exposed in the GraphQL schema. Now for getting the data of this post, we have our models.py, which is defined using SQL Alchemy. It has the same fields: ID, title, and content. Now let's explore the queries.py file. This is the place where we define all our GraphQL queries. So here we can see that there is a class query. So this class will be wrapping or holding our entire GraphQL query operations, and this will be decorated by strawberry.type decorator, which designate it as a GraphQL type. Then each of the individual queries are decorated by the strawberry.field decorator. So here we have two queries, get post and get post by ID. So we can see that get post returns a list of post type objects. So this is the post type we have seen previously defined in the types.py file. So what it does is that it creates an SQL Alchemy session, and it queries all the objects from the post model and returns everything. So that's the operation of get post. Now coming to get post by ID, this has a similar structure to our get post function. Additionally, there is an argument called ID, and its type is strawberry.id. So what it does is that this query will have an additional argument. It will accept an additional argument called ID, and it will return a single post type rather than the list of posts we returned in the previous query. So it fetches the relevant ID from our database and returns relevant post and returns the single post from our database. So let's see that in action. For specifying these queries, I have created a schema.py file, and we have defined our root query class, which holds all our queries. Now coming back to our app.py, let's run our app. Now our app is running on localhost port 5000. Now let's open the Strawberry GraphQL Explorer. So we have created a /GraphQL path. So our endpoint is exposed in the path. Now this is the GraphQL Explorer, which is provided by the Strawberry library. So here we can see the documentation of our API defined. We have seen various query operations. Both of our queries like get post and get post by ID are exposed in this GraphQL schema. Here we can see that the cases were converted to camel case following GraphQL conversion. The return type is specified and the get post by ID is accepting ID as an argument. So let's try out an API. For trying an API, we can either use this functionality of the Explorer. We can just select our required fields and we can run that. So initially I am running the get post query. So either we can use a query and name our operation, or we can simply omit that in case of a query. So this will work. And similarly, if you are naming that and we are specifying the operation type, it will also work. So we have two posts defined and these are successfully returned from our database. Now let's try another second query, get post by ID. Since GraphQL is strongly typed and GraphQL provides the operation suggestions for us, so you can see the auto completion. Now we are seeing an error. It's because we are missing the argument ID. Now let's try selecting the post with ID 1. Now the error is that we need a sub-selection of fields. Like we are not selecting the return values. So let's try ID, title. Yeah. Now on executing the query, we get the result of a single post with ID as 1. Now let's explore some other features of GraphQL. Like here are two fields, summary and created by field, which were not defined in our database. So we can leverage the functionality called custom fields of a custom defined GraphQL type. So we can run the same query requesting these additional fields. So we are seeing the summary. It's a short summary of the entire post content, and there is a created by object returned. So on hovering above, we can see that created by is now returning a user type object which has ID and name. Okay, now let's go back to our implementation and see how this is done. Here is our types.py. These are our fields defined in the database and which are returned directly from the database. Now here is how we define a custom field in post type. We are using the strawberry.field decorator and we are just specifying the name of the field as a function. So we are just selecting the first 10 characters of our string, of our content string in the summary field. And for the created by field, we are returning a custom type. Like we have defined a custom type here, user type, which has ID and name. So we can either return scalar types like string, or we can specify a custom type as the return type of our strawberry field, and then we can provide the corresponding value of the type. Now let's look at the run logs. You can see that the resolving created by field is resolved, and this message is printed whenever we are resolving the created by in our GraphQL operation. Now let's try it once more. So if we are omitting this created by and we are running this post multiple times, so there are no new logs. When we are bringing it back, you can see that this is being logged. So I just want to highlight the fact that the fields are like lazy in GraphQL. The only that which all fields we are requested from our query will be executed. So this is useful in case of like heavy operations like we need to perform a complex calculation to get a custom field. So we can wrap them inside a custom field with their own custom logic. So they will be executed only when the query explicitly requests for that specific field. Now let's look at mutations. Mutations are defined in a similar manner. So we are using strawberry.mutation decorator for defining the same. There is a root mutation class. Now the operation is the same. We are getting the title and content of a blog post as input. Then we will save them to a DB and we are returning the object. Inside the schema file, we are specifying the root mutation type. Now let's see that in action. Now we have created a new post. We can see that new post is reflected in the get post query. So we have completed a basic demo of our microblogging application using GraphQL. Summing up, we have defined a GraphQL view, which is a class-based view provided by Strawberry for exposing our GraphQL endpoint. Then we have defined our types, which all types we are exposing in our queries and mutations. Similarly, we have defined our custom fields. Now for queries and mutations, we have annotated their return types. We have added their arguments, query arguments, and we have added all our operations in our schema. So this is how we define a basic API in GraphQL. Now let's move forward to our next concept, that is GraphQL Federation. So GraphQL Federation or Apollo Federation is a standard or spec for combining multiple independent GraphQL schemas from different microservices. It was created by a company called Apollo GraphQL. So it combines multiple related schemas from microservices, which Federation called subgraphs, to a single unified schema called supergraph. So what it does is that it abstracts away the microservice design from the clients by combining GraphQL APIs or API definitions from multiple services and exposing them as a single endpoint to the clients. So the next question is when to use GraphQL and Federation. So GraphQL should be used where it shines. For example, GraphQL does its best when it's used for internal APIs with diverse use cases. That is when there is multiple clients like internal services, mobile applications, web applications and all. GraphQL does its best. Also, we should move to a GraphQL Federation when it fits our own architecture. If our current architecture is a microservice based one, Federation will fit us best. Also, when our current GraphQL monolith becomes unmanageable due to its complexity, we can think of moving to a federated architecture. So these points are taken from a talk by Mark Andre given at GraphQL Conf. He's a GraphQL Steering Council member. Now let's explore a few key concepts of GraphQL Federation. First, we have directives. Directives are similar to our Python decorators. It decorates a part of GraphQL schema. Here we can see in this query we have added a directive with the email field at include if with email. So this is a variable and we are passing the variable as true in this query. So we can see the email field is returned in the response. If we are making the with email variable as false, this field is omitted from the response. So that's an example of a directive. At include is a GraphQL directive. Now we have a core concept of GraphQL Federation, which is an entity. So an entity is entity is an object type that can resolve its fields across multiple subgraphs. So this will be clearer when we see an example. So this can be simply thought of as a GraphQL type which appears across multiple subgraphs. So consider this example. We have our user type order type and review type. So these all are defined by different services. The order service has its own type called order type. So it has a created by field. So this will be pointing to a user or a user type. Similarly, a reviews have written by field, which can point to a user. Thinking of fields, user service, the user type might have fields like username, ID, etc. Similarly, for an entity, other services can also contribute fields. So the user type can get a contribute field called review count, which is contributed by the review service or the order service. Now we have a custom directive for federation. It's the key directive. So it is used to designate an object type as an entity. Also, the key directive indicates fields that can be used to uniquely identify an object. Here, from the above example, we can see that we are decorating the user type using the strawberry federation type decorator, and we have specifying keys as ID. So this means that the primary key, similar to a concept of a primary key, user type can be uniquely fetched using its ID field. We will see this example in detail in the coming slides. Next, we have a federation gateway or router. So this is similar to the concept of a microservice gateway. So our gateway or router will combine multiple microservice schema and expose them as a single unified endpoint. Also, the router is intelligent, so it holds a logic to resolve entities across multiple microservices. Like if the request contain multiple parts which should be resolved from our different microservices, the router can intelligently route or direct each of these requests. Next, we have a reference resolver function. So this enables the gateway to resolve a particular entity by its key field. Here we can see the example of our user type. The user type has its key as ID. Now coming to the reference resolver function, it will get the key as its argument, and using the key we need to uniquely return our user type. So here in this example we are just fetching the user from the database. So the ID is a primary key in our database, so we can get our user with the corresponding ID, and we can return our user type with all the necessary details from the database. Now let's move on to a demo, and we can make our microblogging application to a federated one. In this federation demo, we have two microservices, the post service and the user service. For the demo purpose, I am organizing them inside a single folder, but in a typical microservice setting, this will have their own repositories. In our case also, these two services are completely independent. Like the user services has its own DB, and I'm using the initDB function to populate our database with two sample users. Then these two are entirely different Flask apps. Our user service is running as a Flask app on port 5001, whereas the post service is running on the port 5002. Here are the models corresponding to our user service. We have a user table. It has basic fields like ID, username, and email. Similarly, the post has ID, title, content, and a column called user. So this stores the user ID of the user who created the post as an integer column. So this is similar to a foreign key relation, but not exactly that, because in a foreign key relation, the both connection will be in a single database, but here we have two different databases which are owned by two different services. So these two are connected. The post and users are connected by means of GraphQL federation. Next, in the user service, we have a similar structure to our previous demo. In the types, we have defined a user type with all the three required fields, and instead of the strawberry.type decorator, we are using strawberry.federation.type decorator, and we are specifying its key field, which means its ID can uniquely identify a user type. Also, we have defined a resolve reference function, which we have seen in the previous example, which gets the user objects from the database based on its ID. And we are returning the fetched user type. Now, here there are user query and users query to get a single user based on ID and to list the entire users in a database. Now, moving to a post service, we have the types here. Here we have defined a user type, which is a federated type, but this post service only has the ID of the user type defined in that. So we are omitting other fields here. Other fields will be exposed by means of federation, and we have our post type, which is a simple strawberry type. It's not federated or it's not shared between multiple microservices. Post type is owned only by our post service. So we are using the strawberry.type decorator. And the difference is that inside the schema, we are using strawberry.federation.schema. We previously used the strawberry.schema class to define the schema, and here we have post as well as post query. Now I have run these two APIs. Now let's explore them in the GraphQL Explorer. So this is our users endpoint, port 5001. So this is the users query, which returns both of our sample users. Next, we have the post query. So each post has a created user. On running that, the user ID is returned. Now let's check the user type here. So this user type is the one defined in the post service. So it only has the ID field, whereas the user type defined in our user service has ID, username and email field. Now to combine them, we might need to leverage GraphQL Federation. Now for federating these two, we need our federation gateway or router. So I am using a tool by Apollo GraphQL, the creators of the GraphQL Federation spec. So the tool is a rover command line tool. So we need to specify the URL of our individual GraphQL microservice using the rover dev command. Now I am adding our users microservices to our router using the rover dev command. I am naming the subgraph as users. So we get a new endpoint. So this is the endpoint to our supergraph. Let's go to that in a second. Now I also need to add our post service at the port 5002 to our supergraph. So the post subgraph has also been added to our supergraph. Now let's head over to localhost port 4000. So we have seen the GraphQL explorers here. So this is a similar tool for exploring our GraphQL queries. Let me zoom it up a bit. So this was our previous post query. We are getting three sample posts we have ingested in our database in the result, but we only have the ID of the user since this is performed using our single subgraph, the post subgraph. Now coming to the router, so the router has federated our posts and user services, and it exposes a supergraph in this port. Now let's try executing the same query. So inside the post, let's select the ID, title, content, as well as the user. So inside the user, we can see along with the ID, username and email fields are also visible. On executing that, we can see that the three posts along with the complete details of the user are returned. So how does our router or the Federation gateway performs that? So we can see that using the query plan. So this is the simplified query plan. Initially, the router will fetch all posts from the post subgraph. Then each of the posts will have an associated user ID like we have seen here. It will have the ID 1, 2. It will collect all these IDs and it will go to the user subgraph. It will send request to user subgraph using all the IDs fetched here to get the remaining fields like username and email from the user, and it performs an operation called flattening. So it combines the result from the post and it combines that with the resulting data from the user. So this is another representation, a textual representation. So it happens as a sequence. Initially, these data is being fetched from the post service. Only the ID corresponding to the user is returned from the post service. The next operation is a flatten operation. So the service users is queried with the IDs which were fetched from the post, and we get a username and email of the corresponding user, and finally these are flattened together to give a combined result. Now let's plan a minor update to our user type. Previously the entire logic and the custom fields defined in the user type was owned by our user service. So what if any other service need to contribute some fields to the user type? So let's add a post count field to the user type. Since the post data is stored by our post service, it will be better or suitable to add the logic related to this field in the post service itself, and this separate service can contribute additional fields to our original user type. So what we have done is we have defined a custom field here, and we have specified a reference resolver, so which will supply the user type with the values which can be supplied from this service. Like this service owns the post count, so the post count is returned along with the key field, that's ID. So what it does is that it queries the post table, and it filters the number of posts by the user, and it returns that as the post count field. Now let's take a look at the our updated GraphQL Explorer. Here we can see this is the Explorer of our supergraph. So all the queries from both the services, user and post service, is exposed here. So now let's query user based on ID. Let's select the ID, email and the post count fields. So here we have to specify the user ID as the argument. So let's check the data of the first user. So yeah, we can see that there are two different posts by your first user, and for the user ID 2, you can see that there is one post by your second user. We can verify the same by executing the post query. Let's select ID title and the user ID. So we can see that there are two posts by the user 1 and one post by the user with ID 2. Now let's explore the query plan for the same. So this was our original query which returned the email of the user along with the post count. So this will be returned by the post service, and this will be returned by the user service. So since we are querying users, the initial request will be going to the user service, then the next request to fetch the post count will be sent to the post service, and we will be flattening this data together. Now looking at the textual query plan. So initially the user service is queried with ID and email fields. So these are owned by the user service. So this can be returned with a single query. Now once we obtain this data, another request is sent to the post service with the key of the entity, that's ID, and using this key the reference solver function will be executed and we will get the additional field, that is the corresponding post count by the user. So initially we started with a simple monolithic GraphQL API and defined queries and mutations. Now in the second demo, we have created a federated GraphQL API with multiple subgraphs, the user subgraph and post subgraph. So we have shared a entity between multiple subgraphs. We have shared our user type. Now we have seen how a microservice, how a subgraph can contribute specific fields to an entity. So that's it. These are some of the references I used for preparing this talk. That's it. Thank you. You can connect with me on LinkedIn and Twitter or X. Also, you can see the slides and demo codes by visiting this URL. Thank you.